Harvey, of course, made landfall last night near Rockport, Texas, as the strongest storm to hit the state in half a century. And the good news is the storm has lost strength, but it continues to pound parts of Texas with strong winds and torrential rains.
August 2017, Texas was about to experience something no one was prepared for. At first, Hurricane Harvey looked like just another storm. Forecast models predicted a normal impact, strong winds, heavy rain, minor flooding. Then it would leave. That is what hurricanes normally do, but Harvey didn't leave. It stopped. And what happened next shocked meteorologists around the world. A storm that refused to move, rain that refused to stop, and a disaster that changed how scientists understand hurricanes forever. This is the story of Hurricane Harvey, of the storm that rewrote the rules of nature. Where hurricanes are normal, along the Texas Gulf Coast, hurricanes are part of life. People expect them. They prepare for them. They recover from them. For over 100 years, storms have followed similar patterns here. They form over warm ocean water. They grow stronger. They hit land. Then they weaken. Nature usually follows predictable behavior, but every once in a while, something unusual happens. Something scientists call a low probability, high impact event. Harvey became one of those events. The beginning nobody noticed. On August 17, 2017, a small tropical wave moved off the coast of Africa. It was weak, unorganized, nothing special. These systems form constantly. Most disappear within days. At first, Harvey looked like one of those forgotten storms. Meteorologists tracked it. But concern was low. Soon, the system weakened. Then it nearly disappeared completely. Normally, that would be the end of the story, but not this time, because 5 days later, it came back, the rebirth near the Yucatan Peninsula, the storm reorganized, warm water gave it energy again. Cloud structure improved, thunderstorms increased, pressure began falling. This caught scientists' attention, because storms rarely recover after weakening this much. But Harvey was entering extremely favorable conditions. The Gulf of Mexico was unusually warm, almost like gasoline waiting for a spark, and Harvey became that spark. Rapid intensification. Within just 48 hours, Harvey transformed dramatically. Wind speeds increased rapidly. Storm structure became symmetrical. The eye became visible. Meteorologists call this rapid intensification. It is one of the most dangerous hurricane behaviors because it gives little warning. Harvey jumped from a weak storm to a Category 4 hurricane. This shocked forecasters because this level of strengthening normally takes much longer, but the Gulf provided perfect fuel. And Harvey used every bit of it. The night everything changed, August 25, late evening, Texas coastline, Harvey arrived with devastating force. Wind speeds reached 130 miles per hour. Entire buildings shook, trees snapped. Power grids failed. At first, emergency planners believed wind damage would be the biggest problem. They were wrong because something invisible was happening in the upper atmosphere, something that would turn Harvey from a dangerous storm into a historic catastrophe. The storm began slowing down. The atmospheric trap, normally hurricanes are pushed by global wind patterns. These steering winds move storms inland, but during Harvey, those steering winds collapsed. High pressure blocked movement north. Another system blocked the west. The storm became trapped. Meteorologists describe this as a blocking pattern. Think of it like traffic. When roads are open, cars move. When roads are blocked, everything stops. Harvey had nowhere to go, so it stayed. And when a hurricane stays, rain becomes the biggest threat. When rain becomes the disaster, at first, rainfall seemed normal. Texas is used to heavy storms. But this was different. Rain continued overnight, then through the next day, then another day, then another. Rainfall totals became shocking. 20 inches, 30 inches, 40 inches. Eventually, some areas recorded more than 60 inches. That is over 5 feet of rain. Scientists later confirmed Harvey produced the largest rainfall total from a tropical cyclone in U.S. history. Houston began to drown. The slow disaster, unlike tornadoes or earthquakes, flooding is slow, silent, creeping. At first, water collects in low areas, then streets, then homes, then entire districts. People often underestimate slow disasters because danger does not look dramatic at first. But Harvey showed how dangerous slow disasters can be. Because once water arrives, escape becomes difficult. Houston faced a unique problem. The city is extremely flat. In some places, elevation changes only a few inches per mile. Water does not naturally drain fast. Historically, wetlands absorbed floodwater. But rapid development changed that. Concrete replaced soil. Buildings replaced grasslands. Because water could not absorb into the ground, it stayed on the surface. Urban flooding became inevitable. Harvey exposed this weakness. The largest rescue effort, soon. Emergency systems became overwhelmed. 911 centers received thousands of calls. Rescue teams could not reach everyone quickly. Then something extraordinary happened. Citizens stepped in. Private boat owners launched rescue missions. This became known as the Cajun Navy-style response. Volunteers formed boat convoys. Ordinary people became heroes. They rescued strangers, families, pets, anyone trapped by rising water. Tens of thousands were saved this way. It became one of the largest volunteer rescue efforts ever seen. The psychological impact: disasters are not only physical, they are psychological. Many survivors later described the same feeling: uncertainty, waiting, watching water rise, not knowing when it would stop. Because Harvey lasted days, stress levels remained high for long periods. This created long-term emotional effects. Scientists now study carefully. Slow disasters often cause deeper psychological strain than fast disasters because fear lasts longer. What scientists learned: Harvey became one of the most studied hurricanes ever recorded because it showed 3 dangerous trends: slower moving storms, higher rainfall capacity, rapid strengthening. These are all linked to warming oceans. Warmer air holds more moisture. More moisture means more rainfall potential. Scientists estimate Harvey carried 15 to 20% more rainfall because of modern climate conditions. This does not mean climate change created Harvey, but it likely made it stronger and wetter. The cost of the storm. Eventually, attention turned toward recovery. Damage estimates were massive, over $125 billion, making Harvey one of the costliest disasters in U.S. history. Entire neighborhoods required rebuilding. Infrastructure repairs took years. Insurance systems were tested. Government response systems were analyzed. Harvey became a case study in disaster economics. Recovery. Eventually, the storm moved away. Rain stopped. Floodwater slowly drained. Sun returned. But recovery is never quick. Rebuilding takes years, sometimes decades. Yet something powerful appears after disasters: human resilience. Communities organized support networks. Volunteers rebuilt homes. Strangers helped strangers. Disasters often reveal both vulnerability and strength. The warning Harvey left behind. Today, scientists see Harvey as a warning, not because it was unique, but because similar patterns may happen again. Urban growth continues. Climate patterns shift. Coastal populations increase. Risk exposure grows. The real lesson is not fear. It is preparation. Better flood mapping, better drainage systems, smarter construction planning, because disasters become tragedies when preparation fails. At first, Harvey was just a storm. Soon, it became a disaster. Eventually, it became a lesson, because nature always teaches, sometimes gently, sometimes dramatically. Harvey reminded us of something important. Technology is powerful. Cities are strong. But nature is still in control, and it always will be. Texas recovered. Houston rebuilt. Life continued. But Harvey left behind something invisible: knowledge. because the greatest disasters often become the greatest teachers. And the biggest question Harvey left behind is simple. Next time, will we be ready? Because when nature decides to change the rules, and it never asks permission,